Let's go to page 317. This is lesson 7-3. The objective of this lesson is to determine the nature of the roots of a quadratic equation by using its discriminant. Okay. So from the previous lesson, we have the quadratic formula. We have x equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay. Now there's something special about this over here. This part right over here. This part is called a discriminant. Okay. So d is equal to b squared minus 4ac. Now this part over here, this will tell you what kind of the roots you're going to have. Okay. So let's go over some example. Okay. So let's go to example 1. Example 1a. So just keep this in mind. Okay. So example 1a, we have x squared plus 6x minus 2 equal to 0. Okay, so now if you were to solve this, okay, so remember so when you have the x equal to use quadratic formula, so you're going to have, so a equal to 1, b equal to 6, c equal to negative 2. So if you were to solve, you got x equal to negative b plus or minus square root of b squared minus 4ac over 2a. So x will equal to negative 6 plus or minus square root of 36 plus 8 over 2. So x equal to negative 6 plus or minus square root of 44 over 2. And if you separate, you got x equal to negative 6 plus or minus, so this will equal to 2 square root of 11 over 2. So x will equal to negative 6 plus or minus, that's going to simplify. So divide everything by 2. So you're going to get negative 3 plus or minus square root of 11. Okay? So in this case, the two roots are real. So again, this is the real roots. And you have plus or minus there. So this is two unequal roots. Okay? So you're going to get 2, right, because of plus or minus. And you could get real because this is the square root, so it's a real number, and it's unequal because it's a plus or minus, so it'd be unequal. So 2 real unequal roots. Okay. And so the way you're going to do it is by just looking at the inside. Okay. So notice this is your d, right? So this part over here, that's the d. That's the d part. Okay. So when d is greater than 0, that's what you're going to get. Okay. So when d is greater than 0, you're going to get real roots. Okay. And it's going to be 2 of them because it's a plus or minus, and they're going to be unequal because one is plus, one is minus. Okay. When you add, subtract, you're going to get 2 real unequal roots. Okay. So from this exercise, we can determine that when d is greater than 0, you're going to get real roots, and you're going to get 2 of them because you got plus or minus. Okay. Okay. Now let's go and do the b. So you have 3x squared minus 4 square root of 3x plus 4, okay, equal to 0. So over here, a equal to 3, b equal to negative 4 square root of 3, c equal to 4. Okay. Okay, so from here, we're going to have x equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so x equal to 4 square root of 3 plus or minus square root of, this one will give me 48 minus 48 over 6. So x will equal to 4 square root of 3 plus or minus, now they're going to get square root of 0 over 6. So when it's equal to 0, this will cancel out, okay? And so that's no more plus or minus. So x will equal to, reduce by 2, you're going to get 2 square root of 3 over 3. Okay? Okay, so again, there's no plus or minus. So if you separate, you're going to, so in this case, so you can see that when d, again, this is the d part, okay? So when d equal to 0, okay, you're gonna get one double root. Okay, this is called a double because the x squared, you're gonna get 2 answers and they are same, right? Because this plus and minus, so 2 answers are gonna be the same. So you're gonna get one double root. One double, and it's gonna be real. One real double root. Okay? So you're going to get one real double root when d equal to 0. So again, you're going to get 1 because there's no more plus or minus. So it's going to be 1. But it's because the reason it's called double because you're going to get 2 of the same answer. Okay? When you try to solve it. Okay? Okay. Now let's go to the 1c. Okay, 1c, you have x squared minus 6x plus 10 equal to 0. Okay, so a equal to 1, b equal to negative 6, c equal to 10. So x equal to, again, we are using the quadratic formula. Okay? So you're going to get negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so x equal to 6 plus or minus square root of 36 minus 40 over 2. So x will equal to 6 plus or minus square root of negative 4 over 2. Okay, and then you simplify, so equal to 6 plus or minus 2i over 2. And so x equal to 3 plus or minus I. Okay, so again, remember, the inside part, this is your d, right? That's the d. That's a d part. That's a d part. Okay. So when d is less than 0, okay, when d equals less than 0, you're gonna have a square root of negative numbers. Okay. And so when you have square root of negative number, you're gonna get imaginary numbers. And so you're gonna get 2 because you got plus and minus, right? So you get 2, and you're gonna get imaginary. And they're going to be conjugate because one is plus, one is minus. Okay, so it will be 2 imaginary conjugate roots. Okay. Okay, so from these 3 examples, we can conclude when d is greater than 0, inside when it's greater, it's going to be real roots. Okay, and when it's equal, it's also real. Okay, again, because whenever you have a negative inside, when d equal to less than 0, okay, then you're going to get imaginary roots. Okay, if it's equal or greater than 0, you're going to get normal roots or real roots. Okay, and again, so when you have a plus or minus, when you cannot get rid of these, you're going to get 2. Okay, when you have equal to 0, then this is gone, so you're going to get 1 double root. So make sure you know the 3 situations. So again, when it's greater than 0, you're going to get 2 real roots because of plus or minus. Okay, and they are not going to be equal. Okay, when d equal to 0, this is going to be gone, and so you're going to get one real double root. Okay, And then when it's less than 0, you're going to get two imaginary roots, and they're going to be conjugate. Okay. Okay, let's go to example 2. Okay, example 2, it says, without solving each equation, determine the nature of its roots. Okay, so 3x squared minus 7x plus 5 equal to 0. Okay, so now we're not going to go through the solving, okay? Because notice over here, we don't need all this part over here. All we need is this part over here to figure out what kind of roots it's going to have, okay? So from the example 1, okay, we don't need all this part, okay? Because from this, we know, we can tell what kind of answer you're going to get. Okay, so again, so you got A equal to 3, B equal to -7, C equal to 5, okay? And again, remember, that's your D, right? So D equal to B squared minus 4AC. Yeah, that's D is the part that's inside here. Okay? Okay. So D is equal to -7 squared minus 4AC. So D equal to 49 minus 60. So D is equal to -11. Okay? So because D is negative, okay, so we have this situation over here when D equal to negative, so you're going to end up with a negative inside the square root. So you're going to get two imaginary roots. Okay. Okay, so this one would be, so in this book it doesn't, you don't need to say how many, so answer just ask. So this would be imaginary roots. Okay. Okay, let's go to 2b. Okay. Okay, you got 2x squared minus 13x plus 15 equal to 0. So A equal to 2, B equal to -13, C equal to 15. Okay, so again, let's go and find D. So D equal to B squared minus 4AC. Again, this came from the quadratic formula. So this is your D right over here. Okay, so again, that's the D part. So let me go and highlight this part over here. Okay. So D is a part that inside the square root. Okay, so again, substituting here. So D equal to -13 squared minus 4 times 2 times 15. So D equal to 169 minus 120. So D equal to 49. Okay, now notice D equal to 49. Okay, so this is a perfect square. Okay, so if you put inside, so when you have 49, you can take it out of the square root. So in this case, there would be no square root. Okay, so in this case, there would be no square roots. So the answer will come out nice. So your roots are real and rational. Okay, so this you're going to get rational roots. Rational means you can put into fraction. Okay, so again, when this is 49, when this part is 49, you can get rid of the square root. So when there's no square root, you're going to get nice numbers, and so there's rational roots. Okay. Okay, let's go and get C. Okay, example 2c, you have x squared plus 2 squared of 3x minus 1 equal to 0. So you got a equal to 1, b equal to 2 squared of 3, c equal to -1. Okay, so you can figure out your d. So d equal to b squared minus 4ac. So d equal to 2 squared of 3 squared minus 4ac. So d equal to 12 plus 4. So d equal to 16. Okay, so we have same situation as the last one. So this is going to be rational roots because it's a perfect square, so it's going to come out nice. So you can take out the square root. So there's no square root. Therefore, it's going to be rational. Okay, rational means fraction. Means your answer can make into fraction. So again, it's going to come out nice. Okay, example 2D. You got x squared over 4 minus 5 over 2x plus 25 over 4 equal to 0. Okay, for this one, before we do anything, I'm going to multiply by 4 to get rid of the fraction. So multiply everything by 4 to get rid of the fraction. So this cancel out. So I get x squared, this cancel, so be minus 10x. This cancel, so be plus 25 equal to 0. Okay. And so again, a equal to 1, b equal to negative 10, c equal to 25. So d equal to b squared minus 4ac. So d equal to negative 10 squared minus 4ac. So d equal to 100 minus 100. So d equal to 0. Okay. So when d equal to 0, okay, that is the situation we had before. That is this situation over here. When d equal to 0, this is going to be gone. Okay, so you're going to get one double root. Okay, so this is going to be, you're going to get a double root. So you're going to get, and it's going to be a rational, because again, when you use perfect square, when there's a perfect square number, there's no more square root. So it'd be rational. So it'd be rational double root. Okay, so again, so the D part, we kind of tell you what kind the answer you're going to get. Okay. Now all this are used to help you to solve problems. Okay. Now on page 319, on the top, it tells you that it says now you have three methods of solving quadratic equations. You can use quadratic formula, you can complete the square, or you can do using the factoring. Okay. So let's go to example 3. And so example 3, you have a kx squared plus 12x plus 9k equal to 0. Okay. And you want to find what value of k will give you a real double root. Okay. So part A, you're looking for a double root. Okay, in order to get double root, okay, you need to get d equal to 0. Okay, so double root means d equal to 0. Okay, so let's go and write the formula first. So d equal to b squared minus 4ac. Okay, and you want a d equal to 0, so you're going to get 0 equal to, right? Again, to get double root, you need to get d equal to 0. So d equal to 0, and b is 12, and a is k, and c is 9k. Okay. So you got 0 equal to 144 minus 36k squared. Okay, I'm going to move this over, so plus 36k squared on both sides. So you got 36k squared equal to 144. And to solve, you divide by 36. So you got k squared equal to 4. And take the square root. So you're going to have k equal to plus or minus 2. Okay? So when k equal to plus or minus 2, you're going to get the double root. Okay? And you can put a k as a 2 in here to get your equation. So when k equal to positive 2 or negative 2, you're going to get the double root. Okay? Okay, now let's go and do example 3b. Okay, so again, you have this equation. And now for 3b, you're looking for two different real roots. Okay, so you're looking for two different real roots. So what it tells you that what you're looking for is you're looking for d greater than 0. Okay, so that's what you're looking for. Okay, so you can, when you're looking for two different real roots, means you want to get d is greater than 0. Okay, okay, so again, you start with this formula. So you got d greater than 0, and d is b squared minus 4ac. Okay, so that's what you're looking for, right? So again, you substitute, right? D, so this is your d. Okay. Okay, so you substitute. So b is 12. So make sure you start with your formula and you just substitute whatever. Okay. And a is k, and c is 9k. And again, whenever you have inequality, you must start with the inequality and you substitute. Okay. So you're going to get 144 minus 36k squared is greater than or equal to 0. I'm going to rearrange things a little bit because I want to have variable in the front. And next thing is I want to get rid of this number, so I'm going to divide by negative 36 to lower my number. So I got k squared minus 4. Now when you divide by negative number, you have to change the direction of the arrow. And 0 divided by negative 36 is still 0. And then from here, we're going to do the factoring. So you got k plus 2, k minus 2. Okay? So your critical value would be negative 2, your zeros. Okay, your zeros are negative 2 and 2. Okay? So when you sketch, okay, and graph's going to be like this, right? And you switch over. So you're looking for part is this part over here. You're looking for, I can think of this as a y. Think of this as y is less than 0. Okay? So you're looking for this part right over here. Okay? Because this is the part is less, that this part is the y less than 0. And so you switch back to k. So you're going to get k is greater than negative 2 and it's less than 2. Okay? So that's what you need to have in order to have two real roots. Okay? Okay, now let's go to part C. Again, different situation. So again, you have this equation, kx squared plus 12x plus 9k equal to 0. And this time, the part C, you're looking for imaginary roots. Okay, so if you're looking for imaginary roots, that means d had to be less than 0, right? Because d is the part that is inside the square root. So when this part is less than 0, you're going to get square root of negative number, and that's where you're going to get imaginary roots. So again, you have to understand what this is trying to tell you. Okay? So again, to get imaginary roots, you need to have the d is less than 0. So again, start with d is less than 0, and then you have to substitute for d. So d is b squared minus 4ac. Right? So that's what d is. Right? From the what we covered earlier. Right? So d equal to b squared minus 4ac. So you substitute that in here. Then you substitute. So b is 12. And a is k. And the C is 9k. Okay. So you can work it out. So 144 minus 36k squared is less than or equal to 0. And I'm going to rearrange. Okay, put it in the proper order. So just like before, the only difference is the arrows are pointing. The only difference is the arrows are pointing different direction. Okay. So you can divide by negative 36. So you're going to get k squared minus 4. Now when you divide, you have to change the direction. So again, just like the previous part, the only difference is that arrow is in a different direction. Okay. So again, you do the factoring. So you're going to get k plus 2, k minus 2. Okay, and then your zeros or your critical value would be negative 2, positive 2, right? Okay. So you're going to get negative 2, positive 2. Again, your graph's going to look something like this, right? But again, you have to switch over to y, okay? Because y is a vertical y is a function of k, right? So you're looking at y is greater than 0. So you're looking the part of y greater than 0 is this part right over here. Okay, so that's this part right over here. Okay. Whereas in the previous one, okay, when it's less than 0, it's down here, right? Okay. So in this case, you're going to get k is less than negative 2 or k is greater than 2. Okay. And so this will be example 3c. So when k is less than negative 2 or when it's greater than 2, you're going to get imaginary roots.